Hello students, in the last class we have seen what is the concept behind Newton-Raphson method. Okay, today we will be solving two problems, okay, based on Newton-Raphson method. Basically, what was the concept? The concept was the tangents are helping us to find out the real root of an equation. Okay. See, I can give you an analogy. Suppose an old man tries to reach to his destination, okay, with a stick. He moves with a stick. Okay, so what does he do first? He first moves his stick, then he moves. So stick is helping him to move forward, right? So consider here the stick to be the tangent. Okay, the tangent is helping us to reach to our destination, that is to find out the root of an equation. Okay, so you can take the analogy of an old man or you can take the analogy of a robot. Okay, robot moves like that only. So he moves step by step. So to reach the destination, tangents are helping. This was basically the concept behind this Newton-Raphson method. So today we will be seeing how to solve it. So we know what is the new value of finding x. It is basically this one. This one already we know. Xn plus 1 is equal to xn minus fxn by f dash xn. Okay. This will help us to solve the problem. Right? So see. Here is a problem. First problem. They are saying find the real root of this equation, and this root should be corrected up to 5 decimal places. Okay. So what will be our first step? First step is to finalize our initial point, that is x0. So first step is to finalize x0. So how do you finalize x0? So see, this is my function, right, fx. So fx is basically this. What I am doing is arbitrarily I put x is equal to 0. You can put anything else, 1, 2. Okay. So arbitrarily, so it is, I will recommend that start from 0. Okay. If the interval is not given. Okay. So put x is equal to 0 first. We are saying that the function value is minus 2. If you put 0 here, you will get minus 2. So this part will cancel out. This one will give my plus 1. Here is already minus and this is minus 1. So minus 1, it will give minus 2. Right? So minus 2 is basically negative. So it is less than 0. Fine. Next we will see, next we put 0.5. You can put anything else because this is our user's hand. So I am saying if I put 0.5, I am getting minus 0.37. Okay, this is still less than 0. Okay, then what I have done, I have taken x is equal to 0.7. You can choose 0.6 also and see what is the function value there. Okay, so when I am putting 0.7, we are saying that the function value is 0.34. Now the sign is positive, greater than 0. So one thing I can conclude that my root should lie between 0.5 and 0.7, 0.5 and 0.7, because for 0.5 my function was negative, for 0.7 my function value is positive. So the root should lie in between, because root is basically the point where my function value is 0. Fine. So I have discarded this 0 initial point because I told you it is like A in the earlier in the bisection method. Okay. So this one I will choose 0.5 as my x0. So this is my first step. First step is to finalize x0. So x0 is 0.5. That means the starting value. Fine. Then basically we need to apply this formula, right? Basically you need to apply this formula. So for that you need the derivative part also of the function. So just I have calculated the derivative part. So it will be 3 dx, so it will be 1 minus cos x, derivative of cos x is minus sin x, and this part will be 0. So this is 3 plus cos x, derivative is minus sin x, so minus, and it is minus already, so plus 3 plus sin x. Fine, you will do the derivative. Next, what we will do, since my starting point is x0, I can find the derivative at this point. So I have found out the derivative of this point. Note, in the previous method I have told you that I can't put directly cos x, sin x, I can't put directly, because this x part should be, for sine functions, cos functions, it will be in degree. So you need to change this, 10 into 180 degree by pi. You need to multiply this, okay, to make it in degree. Fine, so you will get around 3.48. Fine, so this is your function derivative value at x is equal to 0.5. Now we need to complete the rest of the table. So step 2 is to create the table. See, the first parameter is my iteration, my first step, second step, third step, fourth step, like that way. First iteration, okay. So what will be my starting point? Xn, it is n is 0 means x0. x0 means how much? x0 is how much? 0.5, and the corresponding function value is minus 0.37, and then f dash xn, that means f dash x0. f dash x0 is how much? F dash 0.5, that is 3.48. So 3.48. Okay. Now I have just made a little twist here. See, this is my formula, right? What I have done is I have chosen this part, this last part of that equation, and I have written that as h. That is, I am separately calculating that ratio. Okay. Then my ultimate value will be, new value will be this xn and plus h, because h, in h we have already considered the negative sign. Okay, so xn plus 1, xn plus hn. Fine. So this way you will find the first row. So first row is completed. You will get this and this. Now in the second step, the value you have calculated, this is xn plus 1. That means you have calculated for x 0 plus 1, that is x1. So this one will be your x1, mind you. This one will be x1. So this one will be your x1. Fine. Now the procedure is same. Again you calculate the value of function at this point, then derivative value at this point, then again this ratio, then again x plus 1. This will give the x2. Right? So 1 plus 1, x2, that means it is 2. Because here my n value is 1. Okay. So now 0.607101, this will be my x2. So in the next step, so again similarly we will write this. This will be copied here. Then again function value, then derivative value, then again the ratio, then again the new value. This will be your x3. So now here in the last place is x3, then again the same procedure. Fine. Now see where to stop. Now where to stop here? See, it is said correct up to 5 decimal places in the question, right? So see, just check the step 2, this 2 and 3, this last 2. See, 607101, 607101. This is my 5 decimal places. Okay, so this one and this one both are same, right? Up to 5 decimal places. So I need not to calculate further. So let's stop it here. So answer will be 0.60. This is my first place, second, third, fourth, fifth. So we will stop it. My answer will be up to 0.601. So This is where how you will calculate by Newton-Raphson method. So try to fix the x0 first, then try to fill this table. Fine. Now let's see another problem. Sometimes they will give like this. Try to evaluate root over this cube root of 24. Then how will you find this one? See, first of all you need to make a function, right? Without function you will not get this. So how to make a function from this type of problem, this type of statement? So my first step will remain the same, that is to finalize the x0. But before that, first of all try to find out the function. Okay, so see, put whatever they will give, just put it as x. So x is basically cube root of 24. Fine. So now what you can do? Just take x cube, then this 3 will be vanished. So x3, 24. So both sides we take cube. So x cube equal to 24. Then I can write x cube minus 24 is equal to 0. Now this becomes my fx. Fine. This becomes my fx. So for this kind of problem, try to find out the fx first. What is my fx? Okay. Then the other process remains the same. Okay. Here I have made a general rule. What is that? See, if you just map this two, here I made a general statement, general line. S is basically 3 here and Q is equal to 24. Okay, what I have done? Same here, we have done the cube. Here we will take same way. So you will get x to the power s is equal to q. So try to remove these roots. Okay. Whatever they will give, the square root, cube root, whatever maybe. Try to remove this. Okay, so for that you need to multiply in the both sides and take the cube. Then write the fx. X minus q is equal to 0. Same way, and you will get, now you write, instead of x, write xn. Okay, to get the general formula. Okay, so instead of x, write xn. So x will be replaced by xn and you will get this. Okay, now this is your fxn. Now try to map with this one. Fxn we already got, and f dash x sn we can calculate from here. Okay, so see, xn plus 1 will be xn minus this one, that is fxn, by the f dash xn. F dash xn means for this case it will be s xn s minus 1. You know this. Okay, so if you solve this one, just simplify this one, you will reach at this point. So here we are directly getting xn plus 1. So first, whenever they will give this type of question, first try to solve a general expression. Try to reach a general expression for finding a new value. Okay, then what will happen is your table will get reduced. See, this is the n, this is same like n, xn is xn, same. Now these two columns, f dash xn and this hn, we need not to calculate because we have already taken that here. We've already taken that here. So we need not to calculate. Just directly you can calculate xn plus 1 from this equation. Fine. So for this case, if you put 3 here in xn, what it says, s is 3, q is 24, you will get 2.88889. Okay, so this will be your x1, my x0 is 3 and this is x1. Then now again you will calculate x2, then x2, then again x3. Fine, this way we will complete. The procedure is same basically. Now they have told that up to 4 decimal places you need to correct. So we are seeing that in this step and in this step, my up to 4 decimal places, I am getting the same value. Same value means we have reached the destination. Okay. See, in this case, This is my root, right? This is my root. See, if you can see, if I put this one in my function, I'll get this. See, this is almost 0. Almost 0, right? So this is what you know, that root will give the function value 0. So this is almost 0, right? So it says so this is also 0, right? But see, you need to consider how much decimal places they have given. Okay, in that way you can finalize. You can do 2 or more steps, but that will be useless. Okay, so in this way you will solve. Now another thing I missed out here, how do you select this x0? See, cube root of 24, I don't know, I need to calculate, but I know cube root of 27, it is basically 3, I know this. So I can take x0 to be 3. Okay, then we will proceed. See, I am giving another example. Suppose you have been asked to find the value of root 27. Okay, you don't know what is the root of 27, but you know what is the square root of 25. It is basically 5, right? So your starting point will be 5. Okay, that means x0 will be 5 for this case. Then you will proceed. So choose the value such a way that will make this x0 as okay as possible. Okay, that means sometimes it is basically integer, right? These two are integers. It is not always that they will come as an integer. Fraction may also come. Okay, but choose such a way that is very close to this one given in your question, right? Since I know this one, so I can choose x0 as 5. Here I know that cube root of 27 is 3, so I can choose x0 as 3. So in this way we will solve Newton-Raphson method numerical problems. Okay, this will give the real roots. See, you are getting the real roots. Fine. So this much for today. In the next class I will discuss the error in this rule. For the time being, stay safe. Thank you.